In this video, I will be talking about the normal curve, the empirical rule, and z-scores. A normal distribution shows data that vary randomly from the mean. The pattern the data form is a bell-shaped curve called a normal curve. In a normal curve, the mean, median, and mode all exist at the center. So I am going to draw a line in the middle that shows you where the mean, median, and mode all exist. So, in a normal curve, 50% of your data fall above the mean, and 50% of your data are below the mean. So, a normal bell curve is symmetrical around the mean. The graph changes direction at inflection points, and these inflection points mark how many standard deviations you are from the mean. I'm going to connect this first inflection point with a line, and that marks one standard deviation above the mean. The second inflection point marks two standard deviations above the mean. And then I'm going to connect the one below the mean, and that is one standard deviation below the mean, and then two standard deviations below the mean. And we use the symbol mu, which looks like a U, to represent the population mean. And the mean, notice, is directly in the middle, and it is the center where 50% of the data is above the mean and 50% of the data is below the mean. And we're going to use the symbol sigma to represent one standard deviation above the mean, two standard deviations above the mean, and below the mean we use negative sigma, which means below, one standard deviation below the mean, and this is two standard deviations below the mean. Now let's discuss the empirical rule. The empirical rule states that 68% of all values in a normal distribution fall within one standard deviation of the mean. It also states that 95% of all values in a normal distribution fall within two standard deviations of the mean. And lastly, that about 99.7% of all values in a normal distribution fall within three standard deviations of the mean. So therefore, it would be very rare for any values in a normal distribution to fall outside of three standard deviations of the mean. The graph below shows the percentages even broken down further. Now let's discuss z-scores. The z-score is the number of standard deviations that a value is from the mean. For example, a value that has a z-score of 1.5 is 1.5 standard deviations above the mean. Now, if the value had a z-score of negative 1.5, then that would mean that the value is 1.5 standard deviations below the mean. So a positive z-score is above the mean, and a negative z-score means below the mean. The formula to find the z-score is equal to the value minus the mean divided by standard deviation. Or we can use the little formula z equals x minus mu over sigma, because x stands for the value, mu, the little u, is the mean of the population, and sigma, remember, stands for standard deviation. So z equals x minus mu over sigma. Let's do some examples. Number 1, Suppose a set of values has a mean of 85 and a standard deviation of 6. Find the z-score of the value 76. Alright, remember the formula is z equals the value minus the mean divided by the standard deviation. So, z equals the value, which is 76, minus the mean, which is 85, divided by the standard deviation. So 76 minus 85 is equal to a negative 9 divided by 6, which is equal to negative 1.5. So the z-score of the value 76 is negative 1.5. So remember what that means. That means 76 is 1.5 standard deviations below the mean. Number 2. Use the mean and standard deviation from example 1, so the mean of 85 and a standard deviation of 6. And we want to find the value that has a z-score of 2.5. So this time we are given the z-score, so we are going to use the same formula, z equals the value minus the mean divided by the standard deviation. But this time we are given z. We are looking for the value, so we are looking for x. Our mean is 85, and our standard deviation is 6. So remember, to solve this problem, we first must multiply 6 times 2.5. So to get rid of this divided by 6, we have to undo that. So we're going to multiply by 6 to 2.5, which is going to give us 15, and that is equal to x minus 85. And then, of course, to find x, we have to add 85 to 15, which is 100. So the value that is 2.5 standard deviations above the mean is 100. Alright, let's do some more examples that involve the normal standard curve and the empirical rule. Suppose a normal distribution has a mean of 100 and a standard deviation of 10. Find the probability that a value selected at random is in the given interval. Alright, let's start with A. And we want to find the probability that a value selected at random is in the interval 90 to 120. So using the normal curve up above in the right corner, we know our mean is 100, so I'm going to put 100 at the z-score of 0, because remember the mean is right in the middle, because the mean, median, and mode of a normal curve is in the middle. One standard deviation, since our standard deviation is 10, one standard deviation above the mean would be 110, 2 would be 120, and 3 would be 130. One standard deviation below the mean would be 90, 2 standard deviations below the mean 80, 3 standard deviations below the mean 70. Alright, so we want to find the probability between that our value is between 90 to 120. So 90 to 120 would be from negative 1, a z-score of negative 1 to a z-score of 2. So you just basically add up those percentages. Alright, so from negative 1 to 1, remember, is 68. And then if we add another 13.5, that would give us 81.5%. So the probability that a value selected at random is in the interval 90 to 120 is 81.5%. All right, second interval, at least 80. Well, at least 80 would be a z-score of, well, 80 would be a z-score of -2. So we want everything to the right of -2. So we know from 0 to 0 on would be 50%, right? So, and then from 0 to -1 is another 34, and then from -1 to 2 is 13.5. So you can just add those percentages, 50 plus 34 plus 13.5, add up those, and that would give you 97.5%. So 97.5% is our probability that a value would be selected. That would be at least 80. All right, C, at most 110. At most 110 means a z-score that is less than 1. So we are looking for the probability that our z-score is less than 1. Well, we know a z-score less than 0 is 50%. So we have 50%. And then from 0 to 1, because 110 is at a z-score of 1, we add 34. So we have 84%. This is the end of the video on the normal curve, empirical rule, and z-scores. So don't forget to complete your WSQ in your notebook.